I want to do a hard area between polar graphs question in the hopes that I'm just going to do one, and I'm hoping that there'll be enough little pieces to it that add up and you'll understand all the weird or enough of the weird aspects of finding polar area and finding polar area between graphs. I'm going to do the area interior to r equals 2, the exterior to r equals, let's do 4 cosine of 2 theta. My first step should be to sketch a graph, get a sense of what I'm looking at. So if I sketch a graph of this, let's see. Axes, I know it's going to be a rose with 4 petals. I could do this to figure out where my first petal is. 2 theta is going to be 0. Theta is going to be 0. So I have 1 petal here. And because there's 4 of them, they're going to be spaced out nicely. 1 petal's here. The rest are going to look like this. I know that's not a perfect graph, but cut me a break. You know, I don't want to take multiple takes. And the other graph I need to do is I need to do the r equals 2. R equals 2 is just going to be a circle with a radius of 2. So it's going to look like that. The area that is interior to the circle, but exterior to the rose curve, is going to be, ooh, let's make that even more fine. Oh, Tyler, you're so fun. You're so fun. You blow my mind. Oh, highlighter. Oh, that doesn't look good at all, huh? Let's see if I go over it enough times, it'll look better. That's not bad. It's going to be this yellow area. It's going to be 4 of them. I'm just going to find the one, and I can multiply by 4 to find this area, and this area, and this area. I'll just find that one area in the first quadrant. To find the area, first I'm going to draw myself a little bit better picture, a little bit more zoomed in. I kind of have this thing going on where I have a piece of a circle, and I have things kind of coming into the circle. This. I'm looking for just this yellow part. But to find this yellow part, I'm going to do, I'm just missing everything today. I'm going to do the whole sector. Sector, is that what that is? That word just came out, I'm not even sure if I was right. The whole sector minus 2 times this piece, where that piece is, let's say it's like, this is that. I'm going to do the whole sector minus 2 of those, and I should be left just with my yellow area. Near the end, I'll talk about, maybe there's one way to do this to be very wrong, and I'll talk about the very wrong way. This is the way it comes to mind. There are, of course, other ways to do it. This is the way that comes to mind. To figure out any of this, I'm going to need to know some angles, though. I need to know where these graphs intersect. This spot and this spot. I need to know what angles those are, what theta is at those spots. To find where they intersect, I'm going to find where the two R equations come out to be the same value. I'm going to figure out where 2 is equal to 4 cosine of 2 theta, because that's where the R's are going to be the same. So I will do 2 equals 4 cosine 2 theta. 1/2 is going to be cosine 2 theta. I can tell, looking at my graph, I'm looking at 2 points, 2 angles in the first quadrant. So I'm going to keep that in mind as I do this. If 1/2 is cosine of 2 theta, then 2 theta is either, well, cosine of pi over 3 does that. Also, cosine, I'm thinking like x has to be positive, so the angle that's pi over 3 short of 2 pi. In other words, 5 pi over 3. That right there, the word for what I was doing is being bad at trigonometry. So theta is pi over 6, 5 pi over 6. And what is going on? I would believe that this is pi over 6, or maybe this is pi over 6, but it's clearly not because I have this on a graph. This is pi over 6. There's no way this could be 5 pi over 6. 5 pi over 6 has to be along this line, or if it comes out to be a negative radius, it has to be along here. There's no way that 5 pi over 6 is going to correspond to this point. So where did that come from? Where that came from is that this circle is a bunch of radius of 3, but it's also a bunch of radius of negative 3. If somewhere my green curve comes out to a radius of negative 3, it's still going to hit the red curve, even if the red curve is defined, even if my red curve is defined as 3, why am I saying 3? 2. Even if my red curve is defined as r equals 2, if my green curve is ever r equals negative 2, it's going to hit the red curve. It's just going to be thinking theta is negative 2, while the green is thinking it's positive 2. So it's kind of a weird thing going on here. So what I'm going to have to do is I'm going to have to figure out where 4 cosine of 2 theta is also equal to negative 2. I can tell from the graph, because I graphed this on a graph, I cheated. I can tell this looks like a pi over 3, or maybe it's this angle, which I guess would be 4 pi over 3. But how I would actually do it would be, I would take 4 cosine of 2 theta, that equal to negative 2, divide 2 theta must be equal to 2 pi over 3, or 4 pi over 3, which makes theta equal to pi over 3, or 2 pi over 3. Now, if I look at this, between pi over 3 and 2 pi over 3, this definitely could be pi over 3. 2 pi over 3 is here. There's no way this line is going to make a point over here. So this must be pi over 3. Oh, we did it. Okay. That was a struggle, folks. That was really something. So this looks like theta equals pi over 6. This looks like theta equals pi over 3. And at this point, I'm ready to say that my big red sector, and by that I mean this, I'm ready to say that that has an area of 1/2 integral pi over 6, pi over 3, r squared, r in this case is 2, that looks like it's going to come out to 1/2, and a 4 are going to make 2 times pi over 6, which is pi over 3. If you didn't follow the math there, too bad, so sad. I'm kidding, you'll follow. You'll just pause it and look at it for a second. The other way to do this, of course, is area of a sector is a fraction of an area of a circle, so you're going to be fine. Now I need to find the area of this chunk. This chunk, I know, starts at pi over 6, right? This point is the same as this point. It's just kind of a zoomed in type deal. So this is pi over 6. I just need to figure out what this is. So my curve is here, pi over 6, and then as big as it's coming down. I just don't know when it hits the pole. But I can figure it out. I can figure out when does 4 cosine of 2 theta come out to a radius value of 0. Well, that's going to be when cosine of 2 theta is 0, which means 2 theta is going to look like pi over 2, or 3 pi over 2, or 5 pi over 2, or 7 pi over 2, or 9 pi over 2, or 11 pi over 2. I bet you're wondering if I'll ever stop. It's going to look like pi over 4, or 3 pi over 4, or da da da. And all of these theta values are times where my graph hits the pole. I'm looking for the one that happens right after pi over 6. The first one to happen right after pi over 6 is going to be pi over 4. So I can then say that the area of this piece that starts at theta equals pi over 6 and ends at theta equals pi over 4 is going to be 1/2 the integral from pi over 6 to pi over 4 of r squared being 4 cosine of 2 theta squared theta. It's going to be 1/2 the integral pi over 6 pi over 4. My 16 from the 4 squared, I'm just going to write out in front here. 16 times a half is 16 halves. Cosine squared 2 theta. I don't know how to integrate cosine squared, but luckily I do know something cosine squared is equivalent to. I know that cosine squared is equivalent to 1 plus cosine, I double my angle, all over 2. So that looks like it's going to be, this is 8. Yeah, the coefficient from the integral is 8. Take out the 2, it becomes 4. Going to be 4 integral pi over 6 pi over 4. You know what? This video is running a little bit long. I'm going to do the rest of this kind of quickly. Ta-da! I probably made a mistake somewhere. If I did, someone will catch that and they'll yell at me and they'll let me know that I'm the worst math teacher ever. But assuming I didn't, or assuming I did and that you're still able to follow along, I can take this value. I know that that's the area of my green section. I know the area of my red section. So now I know the area I'm looking for. It's going to be the area of the red. Minus 2 times the area of the green, which comes out to pi over 3 minus 2 pi over 3 is going to be negative pi over 3. Then we're going to do minus that fraction. So minus 2 and the over 2 are going to cancel out. It's just going to be minus 2 minus the minus root 3 is going to make plus root 3. Again, I probably made a mistake somewhere, but unfortunately I'm only given 15 minutes to record on this program, and that only leaves me 10 seconds left. And I don't need those 10 seconds, because all I have to say left is good luck. Let me know if I have any mistakes. 2 seconds left. Oh,